Students, this is Unit 4, Similarity, Lesson 4.2 Preview Notes, Similarity Shortcuts. Make sure you get the date and time and a parent-guardian signature. First off, the following polygons are similar. Find the length of the unknown. You're going to work on this page on your own. Restart the video when you are finished. Pause. Welcome back. Let's see how you did. You're supposed to find the unknown, knowing they are similar. And if they are similar, then you are going to be able to do proportions. And it's all about matching and mirroring. Match and mirror. So I'm going to go right here, short side to short side. I'm going to go top to bottom. And I'm going to go long side to long side, top to bottom. Go ahead, we're going to cross multiply here. We end up with 30 parentheses 4x minus 4 equals 24 times 35. Rather than distribute that 30, I'm going to divide that 30 out, and that only cancels what's on the outside of the parentheses. The inside of the parentheses, because it has a minus sign, those are joined. That 30 does not impact either of those 4s. So I come over here, next line, I have 4x minus 4. And this I'm going to go ahead and reduce. I know 6 goes in here 4 times and 6 goes in here 5 times. Then 5 goes in here 7 times, 4 times 7, that's 28. Now I'm going to go ahead and solve for x. I have 4x equals 32. And you should have gotten x equals 8. Let's try another one here. We are told our scale factor from A is 2 to B is 3. Make sure you align those very carefully. Now I'm going to work from A to B. You could have done B to A as well. Let's double check. So from A to B, I'm going to go 2 over 3, x plus 4. Notice I use the arrows to keep my direction. Cross multiply. I have 2 times 24 equals 3, parentheses, x plus 4. Going to go ahead and get rid of that 3. And that 3 only works from the outside. Over here, that's 3, and that's going to be 8. So I have 16. Equals x plus 4, minus 4, of course, and you end up with 12 equals x. You can always put your numbers back in here. So if I put a 12 here, I know this is 16. And then I check my ratio. If I want to, which you can, 8 goes in here twice, and 8 goes in here 3 times. Behold, 2 to 3 ratio. Okay, today we're going to talk about similarity and proportional parts. Similarity and proportional parts. Watch out for these key terms. The word similar, scale factor, and triangle guts. Now, just like we had shortcuts to triangle congruency. So for triangles being completely congruent, we had 4 shortcuts. They were side, 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 angle, side, angle, side, angle, and angle, angle, side. Those 4 shortcuts got us completely congruent triangles. Put this in the margin. Congruency is both same shape, comma, same size. I'm going to wait for a moment for you to write that down. Same shape, same size. That's the definition of congruency. Same shape, same size. The definition of similarity is same shape, different size. Same shape, different size. We have the same shape, but a different size. These triangles are similar. Just like we have shortcuts to congruency, we also have shortcuts to similarity. Watch carefully. The first one says, if you have two congruent, corresponding angles, then the triangles are similar. All you need is two angles for the triangles to be similar. Corresponding means they're in the same position. This is going to look like this. Pair of angles and another pair of angles. So taking a look here, if you have a pair of angles and another pair of angles, and the triangles are similar. Most important thing you want to look for here is watch out for this. If you have a triangle sliced by a parallel line, let's trace these two sides as parallel. Trace them with me. This side, and then you have a triangle that slices it by parallel lines. Technically, you now have two different triangles. Let's trace those. You see those two different triangles? Those two different triangles now, because of the parallel lines, these blue angles are congruent because they are corresponding. In this case, they also share this angle out here. So watch out for this situation because these two triangles, the yellow and the orange, are similar by angle-angle similarity. When you use these shortcuts, you have to use that similarity symbol. So that's one shortcut. The next shortcut says this. If all three side ratios are equal, notice it's the ratios are equal, not the physical sides themselves, then the triangles are similar. And we call this side, side, side similarity. For example, let's go ahead and put a 3 here, put a 4 here, and put a 5 here. 6, 8, and 10. So if these triangles had these measurements and you were to check the ratios, the ratio of 6 to 3 is 2 to 1. 8 to 4, left to right, 2 to 1. 10 to 5, 2 to 1. We have a 2 to 1 ratio, all three. So all three side ratios, it's the side ratios which are equal. Then the triangles are similar. Last one says this. Last one, let's try this. Draw that. This one says if you have side ratios equal, then you have a squeeze angle, and then you have another side ratios equal. Then the triangles are similar. And this spells side angle side similarity. Notice we have a 1 to 2 ratio. Here's also a 1 to 2 ratio. And then a squeeze angle. So this spells side angle side similarity shortcut. So students, let's check out these shortcuts. First, let's put them in the margin, the shortcuts for similarity. Remember, similarity means same shape but different size. And there's three of them. There's angle-angle similarity, side-side-side similarity, and side-angle-side similarity. We're going to do two together here. So let's take a look here. We have a pair of parallel lines, so we always stretch parallel lines out. And because of the parallel lines, we have armpits of the Z, which means we have a pair of angles. We also have another pair of angles, of course, the verticals. So we see the shortcut here. These two triangles, they're not the same shape, same size. They're not congruent, but they are similar. So they are similar by angle-angle similarity. Let's take a look here. Of course, right off the bat, you see you have a pair of vertical angles. Be very careful. We're not told anything else is parallel. Now we're going to check our sides, and it's very important that you match them up very carefully. So I'm going to go short side. I'm going to write the word short. Then I come to the other triangle, and I find my shorter side of that triangle, short. And now I'm going to reduce and ask myself what goes into both of these. And I know 6 goes into both. So 6 goes in here 7 times, and 6 goes in here 4 times. Now I like to check the other way. And here, this is the long side, and this is the long side. I circle. We're going to reduce. What goes into both 32 and 56 is 8, and 8 goes in here 4 times. 8 goes in here 7 times. Notice what we have going on here. We have a pair of side ratios, 7 to 4. We have another pair of side ratios, 7 to 4. We have an angle squeezed between. So these triangles are similar by side, angle, side similarity. You have to get that similarity sign because you don't want to mix it up with side, angle, side congruency. These are two different items. Watch out for the difference between side, angle, side similarity and side, side, side congruency. Ready? This page you're going to do on your own. Pause the video, do the work, restart. Students, get out your red pens. I expect you to correct this in red pen. If it's correct, start. If it's not correct, I expect a little note about what you're going to do differently. Ready? Let's check these sides. We're going to go small, medium, large. So 24 is the small side. Over here, 54 is the small side. Let's check that ratio. 6 goes into 24 4 times. 6 goes into 54 9 times. I'm going to go medium to medium. Medium to medium. And we ask ourselves what goes in here. And we know. Okay, so we take a look here, and you can't really reduce 35 to 81. Let's check this other side here, and 40 to 90, that's long to long, and that does review to 4 to 9. However, because this one side does not reduce, these triangles are not similar, which is a possibility. If you don't have angle-angle similarity, side-angle-side similarity, or side-side-side similarity, that is one of your choices. If it doesn't work for any one of those, then they are not similar. Let's try this one down here. You have a pair of congruent angles. Then you have, of course, your vertical angle. So this was an easy one. This was angle-angle similarity. Before I move on, we need to talk about dimensions. Dimensions. The first dimension is things that deal with length and length only. So, for example, trace a single side. A side length is one dimension. Now, put your pencil right there. Now trace the perimeter and walk it around. Because perimeter just simply adds up all the sides, that perimeter can be unfolded, if you will, into 4 pieces. So perimeter, you should notice, also is just a matter of length. So side and perimeter both have the same dimensions. So when you work with ratios with perimeter and side, think of it as x to the first degree and y to the first degree. Why? Because it is one dimension. Versus area is 2 dimensions. So area is 2 dimensions. Let's shade that. Area is a 2-dimensional concept. Whatever you start in that first dimension ratio, your area goes to the second dimension. So what you need to watch out for is that the dimensions influence your ratio exponents. The dimensions influence your ratio exponents. When you get into 3 dimensions, that same ratio is going to go to the cube because it is 3D. When we get into 3D, the dimensions influence the exponent ratios. This is the main concept I want you to get. The exponent of the ratios change with the dimensions. Say it again. The exponent of the ratios changes with the dimensions. Which leads us to this concept. Things which have the same dimension have the same ratio. Things that have the same dimension have the same ratio. I'd like you to say it out loud to yourself again and fill this out yourself. So if 2 triangles are if triangles are similar, then all the parts are similar, including things like perimeter, medians, altitudes, angle bisectors. Anything that is 1 dimension shares the same ratio as the scale factor, which is also 1 dimension. So if the triangles are similar, the ratio of the sides, so just squiggle 2 sides, will be the same as the ratio, trace the perimeter, of the perimeters. The ratio of the sides will be the same as the ratio of the perimeters. Why? Because side length is 1 dimension and perimeter are also 1 dimension. So things that have the same dimension have the same ratio. same dimension, same ratio. Things that have the same dimension have the same ratio. Again, I'd like you to fill that out yourself. Let's try a problem together, and you'll do one on your own, and we'll be done. So it says right here, a triangle EFG is similar to PQR. Side EF is 12 centimeters. Side PQ is 8 centimeters. The perimeter of EFG is 36. Find the perimeter of PQR. Step number 1 is to actually draw this. So we're going to start by drawing triangle EFG, and they are similar, which means they're the same shape but a different size. So we're going to make it look same shape, different size. So I have side E, F, and G, and then here I have P, Q, and R. Let's start labeling our stuff here. We know E to F is 12 centimeters. P to Q is 8 centimeters. The perimeter of EFG is 36. So I trace all the way around, and for perimeter, I put a little arrow there. That tells my brain I'm going around. So that entire perimeter there is 36 centimeters. And we are wanting the perimeter here. It's not a hard problem if you remember this. Things that have the same ratio have the same dimension. And we just learned that the ratio of the sides, the side over side, the ratio of the sides is the same as the ratio of the perimeters. So using that as our template, we're going to solve. So side over side, circle, plug, check. Our first side, 12. I'm going to go left to right. Over 8. That's my other side. Equals perimeter. Walk it around. We have that. That's 36. My units are all the same. Over an unknown perimeter, you just call that X. From here, we're going to cross multiply. So we have 12 times X equals 8 times 36. Try to do this without a calculator. I'm going to show you that technique again. I'm going to divide both sides by 12. I'm going to circle 12 and 36. That goes in there evenly. That's 3. So we get X equals 24. Now keep in mind what you just solved for. You just solved for the entire perimeter of that triangle. So its perimeter, it's 24. You got to get those units back, centimeters. If you don't have units, you'll get marked down. This page, you're going to do on your own. So read it. Finger track and read, 3 body parts, attempt to draw it, solve, and then restart the video. All right, students, let's check your work. Did you actually pause the video and attempt to do this on your own, or are you just copying? If all you're doing is copying, that's not learning. I need you to pause the video again, do the work yourself, and then restart. Students, you should have a red pen handy. Red pen is to correct. If it is correct, I expect some sort of star or smiley. If it's not correct, I expect you to redo the problem with some sort of notation. All right, so we have here, triangle STU is similar to WXY. So similar means same shape, but different size. Similar means same shape, different size. Is similar to S goes with W, U goes with X, and or T goes with X, and U goes with Y. It says right here the perimeter of WXY is 54 inches. So I go around, WXY is 54. All the way around, that's perimeter with a little arrow. Perimeter is 54 inches. With the little similarity sign. And the perimeter of STU is 36 inches. So perimeter STU is 36 inches. We are asked if T to U is 10, what is X to Y? That's our unknown right there. And we are going to, of course, make a proportion. And the proportion is side over side equals perimeter over perimeter. And the reason we can do that is sides are one dimension and our perimeters are also one dimension. So side over side, I'm going to work left to right. 10 over X equals 36 over 54. If you set this up slightly different, you'll probably still end up with the same answer. So I have 10 times 54 equals 36x. Divide by 36, and the key to multiplying is not multiplying, it's factoring. So first I'm going to reduce 36 and 54. 6 goes in here 6 times. 6 goes in here 9 times. Looks like I can do a little bit more reducing here. 3 goes in here twice. 3 goes in here 3 times. More reducing. I'm going to box that 2 and 10. 2 goes in here 5 times. And my final answer, you should be able to see, 5 times 3 is 15. The easy way to check this is you can reduce. I know this is a 2 to 3 ratio. And 18 goes in here twice. And 18 goes in here 3 times. And so that is also a 2 to 3 ratio. So your side length there is 15. Now remember, the exponent of the ratios changes with that dimension. I'm going to pose a question, and I want you to do your own prediction here. I'm not going to write anything there. I'd like you to predict with this in mind. The prediction is this. If you were to double the side length, double the length of the sides of a rectangular yard, what do you think would happen to the area of the yard? So, for example, if you had a yard length like this, and then we doubled every edge length. So if this were X, this is now 2X. Ask yourself, predict, what would happen to these areas? I'd like you to write a prediction. What would happen to those areas given this circumstance? Okay, students, after you write that prediction, I recommend you set your cell phones for a 2-minute timer and go back and verbally rehearse every single page. That will cement this information in your brain. If you don't review, you'll forget it pretty much instantly. So go back each page and do a quick review of what you learned. Take about 20 seconds each page, 2 minutes total.